All right, ladies and gentlemen, welcome back to Mr. P Helps with Precal. This is Unit 4 lesson, Topic 3, lesson number 3, and we're going to be doing graphing of some polar coordinates. Polar equations. Plot and label the following point on the grid. So we have a polar coordinate, 5 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. 5 pi over 4 would be in this direction in reference to the starting position, but it's -3. So instead of going 1, 2, 3 this way, you're going to go the opposite direction, 1, 2, 3 this way. So that's where that point ends up. Convert from polar to rectangle. So know that x equals r times cosine of theta, like we had done in previous video, and r times sine of theta is for y. So x is going to be equal to -3 times cosine of 5 pi over 4, and y is equal to -3 times sine of 5 pi over 4. Now, these are actually going to be the exact same answer, and the reason why is because 5 pi over 4 is right here, as we had talked about, in the third quadrant, and both sine and cosine are both negative in the third quadrant. So pi over 4, sine of pi over 4 is square root of 2 over 2. So this is actually going to be negative square root of 2 over 2 for both sine and cosine. So then you get -3 times negative square root of 2 over 2, which is going to equal +3 times square root of 2 over 2. Now you can actually change this to a decimal. It's actually, give or take, about 2.12. So this would be 3 times square root of 2 over 2, comma 3 times square root of 2 over 2. So that's the answer in rectangular form, or that's roughly about 2.12, as I mentioned before. All right, so convert rectangular to polar. Okay, so that's square root of 2 squared plus -5 squared. So that's 4, that's 25. That makes square root of 29. So I know it's square root of 29 comma something. So to find that answer, I'm going to do inverse tangent -5 over 2. And that's going to give me inverse tangent -5 divided by 2 is, delete that. So it's -68 degrees. Now, -68 degrees is in the fourth quadrant, but I don't like it being negative, and that's just me. I do want it in the fourth quadrant because 2 -5 is in the fourth quadrant, but I'm just going to add 360 to that, which is coterminal, and that's going to give me 291.8 degrees. So that's the answer that I prefer. Okay, so graphing polar equations. So we're going to start off with different types. We're going to start off with the easiest one, which is circles. So graphing circles in a polar coordinate system is actually fairly easy. This is the format for cosine and sine. So the diameter, the distance of the circle all the way across is A, the number that's being multiplied by cosine of theta. And if it's cosine, it's along the x, and sine is along the y, as you've been doing since trigonometry. So when you look at this question, you know that it has a diameter 3, you know it's along the x-axis. So I'm going to start at the center pole, and 1, 2, 3 is from one side to the other of the circle, and then you draw the circle, and it's pretty easy, not a whole lot to remember. Start at the center circle, but it's -4, which means I'm going to go left. 1, 2, 3, 4. 1, 2, 3, 4. And there's my circle. And this one is going to go along the y-axis, so starting at the center pole, +2, so that's a pretty small circle right there. And this one's -5, 1, 2, 3, 4, 5, which would be this circle right there. All right, so I'm going to go pretty quickly because there's a whole lot of rules when it comes not just to rows, but definitely with the Limacon Graphs. And I want to get through it all in my 15-minute time period. So rows graphs. The first petal always starts at 0 if it's a cosine equation. If it's not a cosine equation, if it's a sine equation, it always starts at pi over 2n, which sounds a little tougher than it really is. And I'll do my best to explain as much as I possibly can, but I might, just do it very quickly due to the lack of time. Length of the petal is A, so that's going to tell you how long the petal is, and obviously it's called a rose graph because it looks like a flower. So it makes sense, and they call it petals. The number of petals, if it's odd, this number that's being multiplied by, so like double angle, like when we did that with the trig unit. So that's the number being multiplied by the angle, in this case, triple angle. So we have 4 times cosine of triple angle, so that's an odd number, which tells me that there's going to be 3 petals. And I know that because odd numbers tell you exactly how many there is. Where if it's an even number, like this one over here, then it's going to have twice as many as that number is. All right, so 3 petals, and they're all going to have a maximum length of 4. It's cosine, which means it's going to start at the starting position. So from here, 1, 2, 3, 4. So there's the first petal. And then 2 pi divided by 3 petals tells me that every 120 degrees is going to be another petal. Because 120 plus 120 plus 120 is 360. So 3 petals, 120 degrees each. So the next petal is going to be right here. So 1, 2, 3, 4, 5. Did I go the wrong one? Oh, it's 4, sorry. So there's the second petal, and then the third petal is going to be right here. And there you go. Now I'm going to go down to the sign question. Because as I mentioned, the only difference between these 2 questions is one's cosine, one's sine. Sign questions do not start the first petal at 0. The first petal is actually going to start at pi divided by 2 times n. N is 3. So the first petal is actually going to start at pi over 6, which is 30 degrees. So 4, 1, 2, 3, 4. There you go. And then if you add 2 pi over 3, that's really adding 4 pi over 6. That'd be 5 pi over 6. 5 pi over 6 would be right here. Now, or you could just use your logical reasoning skills. You can say, hey, it's going to be the exact same thing as this graph, only it's been turned counterclockwise 30 degrees, or pi over 6 radians. Then the next one's actually going to be right here on 270 degrees, and it's going to look just like that. Now, a little bit trickier, we have over here our cosine of numbers that are even, which means this isn't actually going to have 4 petals, it's going to have 8 petals. And because all even numbers always get doubled, which means 2 pi divided by 8, which means it's going to be a petal for every 45 degrees, or every pi over 4 radians. Now, it's cosine, so the first one does start right here. It's 5, 1, 2, 3, 4, 5. All right, and then 45 degrees is another one, and then 45, okay, I didn't make that petal large enough. That's what I get for rushing. All right, there we go. So it's going to look like this, and then it's going to look like this. And then every 45 degrees, I just keep going, and I am rushing this a little bit, so try to be a little bit neater than I am. And then by the time you're done, there should be 8 petals. Okay, this question is going to be exactly the same. It's going to be 8 petals. The only difference is it's got the same maximum length of each petal. The difference is the fact that it's sine instead of cosine. So it's pi divided by 2 times n, which is 4. So this is actually going to not start at 0. It's going to start at pi over 8. Well, pi over 4 is 45 degrees. Pi over 8 is 12.5 degrees. Well, I don't have a line for that, so I'm just going to have to rough guess. It's about right there. That's halfway to here. And then every petal is going to be, so this petal is actually here, and then this petal is actually going to be a little further, and this petal is going to be a little bit further. So it's going to look the exact same as this, only every petal is going to be turned 12.5 degrees. And I'm going to let you be able to figure that out to save a little bit of time. I want to spend a majority of my time, and that I have half my time left, on Limacon Graphs. So a lot of rules going on here. So there's 4 different types of Limacon graphs. We're going to start off with inner looped ones. And the reason why it's called inner looped is because it has an inner loop. As a matter of fact, let me just talk about all of them. This is called dimpled because it has a little dimple right here on the outside. So a dimple like on your cheek, kind of looks like the dimple on your cheek. This is convex because it actually doesn't dimple back in. It doesn't dimple back in. It actually goes outwards. It convex. It doesn't come back in. This is called cardioid, and the reason why we call it cardioid is because, well, it looks like a heart. So cardioids are like this. Now, what you should notice about these is that A and B, so there's rules here for A and B. A can either be bigger than B, A can be a lot bigger than B, or it can be smaller than B, or they can be equal. So that makes all 4 of these different types of graphs. So it's an inner loop when A is smaller than B. And it doesn't matter if it's plus or minus. It doesn't really matter what kind of equation it is. It's not both. It's not like square root. It's just one or the other in this case. So what if it's 2 plus 3? Well, 2 is less than 3. That's how I know it's going to have an inner loop. And the inner loop's always going to be the difference. How much less is A than B? So in this case, 2 is 1 less than 3, which is the reason why the loop is 1 big. Now, these 2 points are always going to be A. So whatever that distance is, and the fact that it's sine is telling you that the loop is going vertically along the y-axis, which is kind of like circles. If it was cosine, then the inner loop is going to be along the x-axis. So this is sine. So I know the inner loop is going to be going up and down. And I know it's going to be going up. So 2 minus, this is minus, which means it's going to be going down. So the inner loop is going down. It's a loop of 1. So it's a little tiny loop right there. Okay, and I also know along the x-axis is going to be 2 away, which is here, 1, 2, and here. So those are like these 2 points. So it's going to look a lot like this graph, only it's going to be flipped and it's going to be going upside down. Now notice that this point was 5 because 3 plus 2 is 5. 3 plus 2 is also 5. 1, 2, 3, 4, 5. Now that I have all my key points, now it's just a matter of graphing it to the best of my ability. So here, curves around, and then, okay, I didn't do a very good job of that. So it curves around to here, and then back. Okay, I should have curved that a little bit better. Okay, that's pretty good, though. That works. So 1 plus 2 times cosine. So it's plus, which means it's going to be facing up. Actually, it's not facing up because it's cosine. It's actually facing to the right. So I know the inner loop is going right. And I know there's an inner loop because 1 is less than 2. So it has a loop of 1 because that is 1 less than 2. If you add them together, you get 3. 1, 2, 3. So you know the maximum value is 3 to the right. Once again, it's going right because it's cosine. Why is it right, not left? Because it's plus. A lot of things to remember here. And now, how far away are the 2 points along the y-axis? Well, they're 1 away. So this one's 1 away. This one's 1 away. All right, so it's going to be a little hard to graph. So something like this. That'll work. All right, so what about dimpled? Dimpled is when A is bigger than B, or you would actually say, to be specific, is that when A divided by B is less than 1, because it can't be double it. So A is more than B, but it's not quite double it. So it's going to look dimpled like this. So it's not going to hit this point like here, like a cardioid would. It's actually going to be dimpled a little bit off. All right, so notice that, first of all, this is cosine, which means the reason why the dimple is going left to right, which makes sense. This one's a little tricky because this one's 4 angle, and I'm going to try to keep this simple as I possibly can. That's the same thing as 1 times 4. Keep in mind, this is like 1. So this is bigger than this, and it happens to be 1 times 4 is 4, so 5 is not twice as big as 4. So 4 is not twice as big. Okay, it was not supposed to be twice as big. I'm going to change this equation to 3. So 3 plus 2 times sine of theta. So first of all, you know that the dimple's going up and down. You know it's going up because of the plus sign. And you know that this point right here and this point right here was 5, which is the same as this point, which is the same as we did up here. So 1, 2, 3, 1, 2, 3. The difference between them was 1. Difference between these is 1, so you know the dimple is only 1 away. And 3 plus 2 is 5. 1, 2, 3, 4, 5. Now, if you can find those key points, the rest is just your artistic ability of drawing, which is... Okay, that'll work. That's, best I can do there. What about this one? Cosine means it's actually going left and right on the dimple. And it's 1 less. It's actually going left because this is subtraction. So the dimple should actually be 1 less, like that. 3 away, 1, 2, 3, 1, 2, 3. And then add those two together, you get 5. 1, 2, 3, 4, 5. Okay. So from here, curved around, dimpled. All right, don't think I did that one too well, but that'll have to do. And I'm going to run out of time.